Cyprus Island has very limited water resources. The right way to find a long-term solution of water shortage problem in coastal land appears to be possible by transferring water from Turkey to Turkish Republic of Northern Cyprus. This major project has three phases named Turkey side, Sea Crossing and Turkish Republic of Northern Cyprus side. Water taken from Alaköprü Dam to be built in Turkey within the scope of the project will be transmitted to Geçitköy Dam by an underwater pipeline. When we look at the Turkey side, concrete plate lining rockfill type Alaköprü Dam, which will be built on Dragon River in Anamur district of Mersin, with total storage capacity of 130.50 million cubic meters, constitutes the basis of project. The height of the dam will be 93 meters from foundation and 88 meters from the riverbed. A hydroelectric power plant with installed capacity of 26 megawatts is also planned to be constructed on the outskirts of Alaköprü Dam. Other stages of Turkey side of the project contains construction of 23-kilometer long transmission line with 1,500 millimeter diameter, aluminum balancing tank of 10,000 cubic meter volume and sea entrance valve rooms. Turkish Republic of Northern Cyprus side of the project involves construction of Güzelyalı pumping station with installed capacity of 5 megawatts, 3,157 meter long ductile capped iron pipe force main with 1,400 millimeter diameter. Geçitköy Dam, which has a height of 65 meters from foundation and 58 meters from riverbed with storage capacity of 26.60 million cubic meter and Geçitköy pumping station with installed capacity of 16.40 megawatts. Sea crossing. Sea crossing phase of Turkish Republic of Northern Cyprus water supply project will be the first in the world with its high-density polyethylene pipeline of 80 kilometers, 151 meter length, and 1,600 millimeter diameter, crossing the sea in a suspended position at 250 meters below sea level. Sea crossing pipeline components. In Turkey and Turkish Republic of Northern Cyprus shore crossing sections, sea crossing pipeline will be buried under seabed until a water depth of 20 meters is reached and will be laid on seabed in the sections between 20 meters and 280 meter water depth with its stability provided by means of concrete reef blocks. When 280 meter water depth is reached, 500 meter long single piece pipes will be mechanically connected to each other and suspended system will start. Installation steps. Installation of sea crossing pipeline. The installation of sea crossing pipeline will be completed in several steps according to the sections of crossing. These steps comprise of shore crossing section installation, on bottom section installation, anchor and buoyancy module installation, suspended offshore section installation, and tie-in installation. Shore crossing section installation. This installation section of the trench pipeline starts from sea entrance valve room up to a water depth of approximately 20 meters. In this section, an open cut trench will be excavated partly using onshore equipment and partly using offshore equipment. The deep water trenching will be performed by a cutter section dredger and the shallow section by a backhoe from a pontoon. High-density polyethylene pipes trimmed with concrete sleeves attached and packed on the sea will be pulled to its desired installation location. After installing pipes trimmed to onshore pipeline section, it will be fluted into the trench in a controlled manner from the sea to shore. Backfilling will take place after pipeline installation. On bottom section installation. On bottom section of pipeline covers the section that stretches from 20 meters to 280 meters water depth. For this section, no trench excavation will be made. The pipe string with weight load attached at intervals of 4 to 7 meters will be pulled to installation location and fluted to seabed in controlled manner. Before floating to the seabed, the pipeline will be controlled by vessels for lining up. Anchor and buoyancy module installation. Installation of gravity anchors will start firstly by putting base structures on position using acoustic positioning system. Then buoyancy module, center and ground weight will be assembled overboard into a single unit and will be sunk into the sea. This unit will be locked into the anchor base structure by a remote operating vehicle. Offshore pipeline installation. Offshore pipeline installation will involve two main phases, one being assembly of pipes to Y-piece and the other being connection of assembled pipes in Y-piece to buoyancy module. Two pipe spans assembled in Y-piece will be lowered to sea level. These two pipes will be lowered to the predetermined depth with the help of a temporary buoyancy module and a clamp weight. Meanwhile, installation vessel will perform a new Y-piece installation for the next span. Remote operating vehicle will perform final connection between Y-piece and pre-installed buoyancy module at 280 meters depth by removing the temporary clamp weight and the buoyancy module. While the installed system is dragged by a vessel from the last installed Y-piece in order to maintain its tension to prevent recoil, the installation of next span will be started. Hence, the tension of the system will be maintained at the same level throughout the entire process. Tie-in installation. Two types of tie-in are discerned. The first is tie-in located between the shore crossing section and the on-bottom section. Second is the tie-in between the on-bottom section and the offshore suspended section. The second type can also be called as transition block installation. Transition blocks connect on-bottom and suspended sections. There are two blocks concerning the transition from on-bottom section to suspended section at Turkey side and from suspended section to on-bottom section at Turkish Republic of Northern Cyprus side. These transition blocks will contain the identical half-wide pieces to be used at the ends of the first and last pipe spans of suspended section. The base structure of anchors with driven piles will have been pre-installed to their determined locations on seabed. Half-wide piece will be connected to transition block using a connector overboard of installation vessels. Pipes connecting the sections will be attached to the half-wide piece and will be lowered to the seabed with a guide wire. The guide wire will be bound by the remote operating vehicle to both the pre-installed anchor base structure and the winch on board the vessel. The assembly will be pulled down and the connector will be locked into the anchor base structure. In the next step, the unweighted 1,000 meters pipe section will be stabilized to the seabed by using saddle-shaped weights. This major project, with its plans to be completed in 4 years, will provide means to transmit 75 million cubic meters of water to Turkish Republic of Northern Cyprus through a pipeline of 106.3 kilometers. With the realization of this project, Turkish Republic of Northern Cyprus will have a water resource to compensate its projected water need for 50 years. This transmitted water can be used as potable, industrial, and irrigation water, and by the help of irrigated farming in 4,824 hectare area, will be a great contribution to the economic development of the region.
Evet, öğrencilerimizin soruları. Have you any question?